Welcome back to our next section in this three-section module. So this is section 9.4. And in the last one, we talked about the greenhouse effect itself. Now we're going to take a look at the changes in the concentration of greenhouse gases in recent years. All right, so let's get right into it. So in this set of graphs, which is going to be most of what we are doing in this section, we can see the changes in concentration of carbon dioxide, methane, nitrous oxide, as well as the fluorocarbons. So we can see a steadily increasing trend for both carbon dioxide and methane, nitrous oxide as well. And then for the CFCs, they increased quite a bit until about 1990 or so, and then they started to steadily decrease a bit as a result of them just not being produced as much anymore. All right, so what was the reason for that? I want you to think about that based off of what we talked about in 9.1 and 9.2. All right, but the hydrofluorocarbons have been steadily increasing ever since then as well. Okay, so over here we can see a bit of data in reference to temperature. Okay, so this has been the average temperature. That's what this line is referring to over the past century plus. And the bars, the blue bars, represent when the temperature was lower than the average temperature over this span of years, and then the red bars are when the temperature was greater than the average over this span of years. Okay, so we can see a general trend of increasing temperature, especially since the 1980s. Okay. And what we're going to be investigating is, how is this related to this? Well, we can clearly see that there has been an increase in carbon dioxide, methane, and nitrous oxide, as well as our fluorocarbons over the past 30, 40 years. And the temperature has been pretty steadily increasing over that span of time too. So the question is there a relationship? Okay, so what are the major anthropogenic sources of carbon dioxide and methane? So over here, we've got carbon dioxide and transportation, electricity. These are talking about burning fossil fuels as well as industry, and honestly, this as well. So that is the main source of carbon dioxide. And then over here, what are the major methane emissions? So enteric fermentation, that's the digestion of animals like cows. They produce methane, so that's a big source. Just leaking of methane from these sources, either leaking of methane or the production of methane through the various processes here. Methane buildup in landfills from the decomposition of the trash, and so on. Okay, so the major sources of nitrous oxide, so the agricultural soil, so a lot of times nitrous oxide gets produced as a result of the application of fertilizers. Okay, so that is clearly the biggest source there. And then our fluorinated gas emissions. So what this means right here is substitution of ozone depleting substances. So instead of CFCs, what we're using instead, well, are HFCs, right? Okay, so just the substitution of the CFCs. Well, unfortunately, we're still using fluorinated carbons that are a big influence in the greenhouse effect. Now altogether, okay, which ones are the largest emissions? Well, carbon dioxide clearly is the largest emission out of all of them. It is 4/5 of the entire emission spectrum here of all of our greenhouse gases. Okay, and again, putting it all together, where does it all come from? Well, remember, carbon dioxide, that is mainly from the burning of fossil fuels, which is mostly these things. Okay. So now, in this part of the section, we're going to look at, well, now that we've been increasing the concentration of greenhouse gases, what are some of the effects that they will have? Well, first of all, with more greenhouse gases, that's going to increase the temperatures of our atmosphere, largely throughout the whole world. And what that will do, ice is going to melt. Okay, so ice on land is going to melt, and when that does, it's going to flow. And when it flows, it's eventually going to find itself in an ocean, and that will increase the volume of the ocean, right? So think of this as like dropping an ice cube in a glass of water, right? You're adding water to it, okay? Eventually that ice is going to melt and increase the volume. In this case, the ice is not in the water already, so it will be coming from the land, and as such, increase the volume of the ocean. Ocean waters, as they warm, okay, just like the atmosphere is warming, ocean waters will also warm because water is a big absorber of heat. The ocean water is going to expand, okay, as things get warmer. The volume increases, so water is no exception there. And another big problem is as ecosystems start to warm, and ecosystems that previously were inhospitable for certain species are now ideal habitats for species that perhaps carry diseases. So vectors such as mosquitoes, their range may expand, and that could cause a problem for human populations. Okay, so we're talking about populations of animals, plants here. So the destruction of habitat as a result of the warming. If certain species die out, that will cause food sources to disappear. And some species have a very narrow range of temperature tolerance, and as that increases, they might not be able to survive. And not only that, but think about how as ice on land is melting and going into the ocean, well, guess what? That's fresh water, and that's going to decrease the salinity of the ocean water, at least in the immediate area. So that could throw some species, again, out of their range of tolerance of salinity as well. So changes in temperature, winds can increase storm intensity. Hotter weather could also mean drier weather. That could increase the possibility of fires as well. And for animals that need to hibernate or migrate, this could impact what they've been doing for many, many generations. Okay, and that is all for section 9.4. So we've got one more section that will continue to look at global warming and climate change.